Introduction. In this era of globalization, there is increasing numbers of vehicles on the road, which resulting in overflow cars in parking spaces, whereby the drivers sought to park anyway they feel safe. This action will cause traffic congestion, double park, and most importantly, disruption for an emergency vehicle to pass through. So, the main goal of this project is to suggest a prototype of a parking system that was safe and efficient for public use. The autonomous parking system will require less surveillance with improving security and space-saving building. Next is the objectives. There are 3 objectives for our project. Firstly, easy accessibility to parking spots. Secondly, to provide a safer parking spots. We want our customers to feel safe when using our vehicle integrated parking system service. Lastly, our aim is to build a convenience parking method. There are several scopes involved in this project. There are literature review about the design from any possible resource. Secondly, design the model of the parking system. Next, fabricate the design using material that has been selected. Last but not least, test the design in demonstration. The next slide is problem statement. Before starting this project, we noticed 6 problems that may encountered with people nowadays. Then, we come up with the idea of doing this project named Vehicle Integrated Parking System. The first problem is limited parking spaces, especially during peak time. Next, time-consuming and different parking policies. Thirdly, excessive automobile usage. Fourthly, cars parked are not from the surrounding area. Next, lack of information on which parking is available. Lastly, safety concern. Based on our previous study, we referred to these 4 types of parking system before finalizing our project. There are automated parking facility EcoPark. This parking system is an underground parking capacity of 50 or more automobiles. With an average retrieval time of 32 seconds, it is a very efficient system. The average time it takes to drop off or collect a car is 32 seconds. Then, automatic parking and high capacity land is effectively utilized. Next, towering parking system. This parking system uses the concept of multi-level towering building design. This design has the capacity for up to 60 cars. It is also a space-effective installation whereby it consumes only 3 parking spaces. The weight maximum for this design is 2,200 kg. Next, vertical rotary smart parking system. This parking system is an economical parking system because it requires 50 square meters for capacity of 50 parking spaces. It is convenient as customers can use PLC automatic control, a button or a swipe to access car function. This system is fast and can save customers time. This system is widely used in shopping centers, commercial buildings, hotels and so on. Next is live sliding parking. This parking system is the most useful parking products in the parking industry. This because it has many types and can be combined with foundation pits on the ground. Such equipment has strong adaptability to the site and low requirements for civil works. This parking system can build out of doors or in the basement of building. One of the advantages of this parking system is high space utilization, safe and reliable equipment. This parking system is easy to operate and maintain. Next slide is customers and competitors. Customer is a person who buys goods or services from a shop or business. Our targeted customers are apartment residents, airport visitors, shopping mall visitors, and government buildings such as hospitals. Competitors is an organization or country engaged in commercial or economic competitions with others. Our targeted competitors are smart parking system, towering parking system, many rotary parking, and mechanical automated parking system. Next slide is business opportunity. The Smart Parking System project opens a walk of life for operators such as securities and cleaner, while the professional will work 9 to 5 managing the system. This will open a pitch for larger customers such as apartment residents, airport departures and arrival visitors, shopping malls and government buildings. The targeted customers will improve the efficiency of vehicle flow and management, thus refining their status and value.
Today I'm going to present about customer requirement and engineering characteristics. Okay. For the first customer requirement is easy accessibility to the parking spot. And the engineering characteristic is an access card of smartphone application. The use unit is time, which is second. The customer requirement number 2 is safer parking spots. And for the engineering characteristic is limited access inside the system. And the unit is Newton per area. The customer requirement number 3 is weatherproof, and for the engineering characteristic is resistant weather. The unit is degrees Celsius. For the customer requirement number 4, which is convenience parking method, and the engineering characteristic is automate drop and walk parking system. The unit is time. For the customer requirement number 5 is vehicle capability technology, and the engineering characteristic is detachable allowable types of cars. The unit is kilogram. And the last customer requirement is number 6, which is less failure, and the engineering characteristic is probability of failure. The unit is Newton per area. Next, I will talk about constraint and relevant standard. There are 5 constraints, which is financial, client system demand, public interest, quality control, and environment situation. For relevant standard, there are 3, which is space-time, payment system, and lastly is safety. Now I'm going to talk about product design specification, key project deadline, physical description, and market identification. For the first product design specification is our project name, which is Vehicle Integrated Parking System. Number 2, our project is provide systematic automation and organized parking space. Number 3 is about special features. There are 3 special features, which is accessible by using an access card or through smartphone application. Number 2, drop and walk parking method. And number 3, turf proof. For the fourth product design specification is key performance target. There are 3 key performance target, which is weatherproof, easy parking method, and lesser failure percentage. The last product design specification is user training requirement name. For the key project deadline, we have 1 until 6 months to finalize design and report. The physical description is number 1, external dimension. For the prototype, the size or the dimension is 50mm times 30mm times 10mm, and 4 compartment for each car is 80mm times 70mm times 120mm. The material is to be determined. For the market identification, number 1, the target market for this product will be residential area and hospitals. Number 2, expectancy of 1 to 2 years of market acceptance and expansion throughout the country in the 3rd year. Number 3, initial production of the actual product will be based on the member of pre-order. This brand name is Vehicle Integrated Parking System, which is our project name. Next is about financial requirement. There are 4 financial requirements, which is number 1, pricing policy over the life cycle. Target manufacturing cost to be determined. Estimate retail price is 40% higher than the target manufacturing cost. And number 2 of financial requirement is the warranty policy, which is 5 years yearly inspection. And number 3, expected financial performance or rate of return on investment is more than 20%. The last financial requirement is level of capital investment required is to be determined. For the life cycle targets, there are 4 life cycle targets, which is number 1, useful life and shelf life is more than 5 years expectancy. Number 2, cost of installation and operators to be determined. Number 3, maintenance schedule is yearly inspection and maintenance. And number 4, reliability, mean time to failure is 5 years. Okay, next I will talk about manufacturing specification. There are 2 manufacturing specification, which is number 1, as for the prototype, all framing, electrical motor and gear component will be assembled in housing. And number 2 is suppliers. The supplier is the name. And the next part is social, political and legal requirement. There are 4 social, political and legal requirement, which is number 1, safety and environmental regulation will be followed. Number 2, standard research federal regulation on available land. And number 3, safety and product liability. The safety aspect in the maintenance of the financial product of the final product will be reviewed and implemented. And the lastly is intellectual property. I will investigate the patent potential.
What is a concept design? A concept design is a starting point on visualizing the product idea with a multiple image. From the customer surveys, product benchmark, and product design specification, we came out with the customer requirement and engineering characteristic needed to draw our concepts. Through that, we came out with the functional structure flowchart. The functional structure flowchart represents the process in our smart parking system, which we call Vehicle Integrated Parking System, from the car park on the platform until the customer retrieve back without entering the building structure. By using the flowchart from the previous slides, we came up with 4 individual concepts or options on how the mechanism would work on the assigned function. The assigned function is starting from the payment method, which using either QR code, a coupon, a ticket, or a manual payment fee, which requires a hard cash. And for the next function is a car pull inside the building, either using a gear and rack, a belting system, or the customer itself park the car into the building. And for the next function is pulling and pushing the car into and out of the multi-level parking, which is the car park on the platform. The platform is being pulled out or pushed into the multi-level parking. And for the next part is lifting the car, which is lifting system. It is came up with us with the different ideas which we use as a scissor lifting, a screw drive, or a pulley system. For the next one is energy, which is the electrical and mechanical. For the movement is either horizontal, vertical, moving forward or backward, left to right. And then for the tire lock, which is for the safety, to avoid the car from moving around when the platform is moving. It is either a screw lock or a strap. For the next one is the building. The building is of course the multi-level and the weatherproof. Part 4 for the individual concept. On this individual concept slide, we use a combination of function to produce our concept 1, concept 2, concept 3 and concept 4. The combination is the tire lock. For the first combination is the tire lock and the platform movement. And then for the next combination is the car lift and the platform placement, which is the car lifting system. The lifting system and the platform placement from the lift to the multi-story parking structure. And the next combination is the platform placement and the calling or payment system, which is the customer want to call back or want to retrieve back their vehicle from their park lot. They will just have to pay or insert a certain code on the counter. For this next slide, I'm going to explain concept 1 and concept 2. For the concept 1, which utilizes the towering concept. This towering concept utilizes 3 parking space, which is quite a space saving because the structure is stretched vertically above that can withstand a capacity of 8 cars on a 3 parking space. This towering concept consists of a lifting system and a rotation system, which drive by an electrical motors. For the payment of this towering concept, they use a numbering system to call out the car from a multi-level parking lot, and you can pay the fee on the counter. For the concept 2 that utilize a puzzle concept is a 2-story parking system. This 2-story parking system designs allow a multiple car entry and exit at the same time, which reduce the time saving to park the car. And also the payment system is located besides the entry to ease the customer using a coupon or ticket to pay. For concept 3, which utilize a dual building concept, is a double-sided multi-level parking structure with the platform consists of a lifting system move horizontally and vertically between the building structure. The parking system uses 1 entry and 1 exit. The final concept is concept 4, which is the rotary concept. This design utilizes 2 parking spaces that has a capacity of 8 cars. The mechanism of this design is a car park inside the parking structure, and then the parking structure will circulate or rotate the platform to provide an empty parking lot. The payment system is using an RFID card, and the card is used to detect the payment and register the cars for the next parking. For the next slide on concept selection, we filtered out the 4 concepts through a screening method with the criteria: the absolute and relative utilizing a Pew chart. A Pew chart is a quantitative technique used to rank the multi-dimensional of option set created by a steward Pew. The relative filtering was based on engineering criteria from ease of maintenance until developing cost. For scoring method, we use the weight decision matrix to rank the concept by design and fabricating feasibility, the most suitable condition. The result came up to concept 3, which is the dual building concept. From the previous slide, concept 3 entering the final design phase, where the rough sketch to visualize the idea. From this slide, you can see the top view sketching the slotting mechanism moving horizontally and vertically. From the functionality slide, we state 4 general functions known to the public for the payment system. For the first one is an access card where the customer required a monthly subscription to use the card. The next one is tow and apps. This can be an alternative method if the cards is not available when entering the parking lot. The numbering system is used to call out the leaf for the vehicle retrievement from the parking lot. Finally, the conventional parking coupon, where the customer must buy the coupon from vendors or straight from the counter at the multi-level parking.
In this chapter, I would like to explain further on the embodiment design. After the final design is constructed by using SolidWorks, the structural analysis of the finite element analysis of the design is being simulated by using ANSYS. As shown here, there are 2 critical components that are being simulated, which are the parking pallet and the parking platform. As for the structural analysis of the parking pallet, the load is being applied on the tire pathway of the pallet, at which it represents the force acting by the car tire movement on the top of the pallet. As for the parking platform, 2 different loads are being applied on the parking platform as shown here. The load represents the pulling process of the parking platform and load from the parked car. The total deformation results are gained, and we found out that the deformation are mainly formed on the tire pathway from the pallet and deformation on the roof and the base of the parking platform. Next, several project calculations were made in terms of engineering analysis, such as the motor calculation for the electric motor use, mass moment of inertia of the gearing system, and from the surface area of the car, we can also determine the force acted on the car and total stress applied on the top of the sloping platform. In this slide, I would like to explain more on our design for manufacturing and assembly, or known as DMFA. As you can see, DFA, which is designed for assemble, and DFM, designed for manufacturing, is a combination method used to optimize easy of assembly, simplifying and refining at a lower cost for the best product. Therefore, assembly chart is constructed components by components to visualize the procedure and its inspection process. From the assembly chart here, first component being constructed is the parking platform, and its sub-assembly consists of the platform itself, tire lock, conveyor belt, and a sensor. The component will then undergo the first inspection. Therefore, the first assembly is completed. Next is the horizontal moving platform assembly, which its sub-assemble consists of platform rail, gear and brake, and electric motor. Then the process assembly of vertically moving platform, multi-level parking structure is being repeated complete with its inspection process respectively. Also, the cost reduction of the analysis is also gained, where we can determine that the initial cost for standard conveyor belt costs around 100 ringgit, and after reduction, the customized size of conveyor belt cost is only around 45 ringgit. In the next slide, to avoid failures, failure modes and effect analysis, FMEA is employed to our project. FMEA starts at the very beginning of the design process and continues throughout the product or services life cycle. As we can see from the table, high RPN value is at the slotting mechanism, which the failure mode is jamming, thus causing slotting mechanism to stop working. Therefore, redesigning and improvements are performed by replacing the chain conveyor with rubber conveyor. Thus, after the improvement, the severity and detectability values are highly reduced. Lastly is the human factor, where we study the interactions between our operator worker in the way they work with the system. By applying the ruler table as shown here, we can determine that the score ranking of the operator's exposure to the ergonomic risk factors. An ergonomic evaluation technique to recognize hazard factors of the stance, power, and muscle hazard factors are done all together for table A and table B. The scores are 3 and 4 separately. All stances are for the most part grouped at class 2 and class 3. Thus, it is perceived that the gathering individuals don't confront a basic postural issue concerning ergonomics. It is very well may be seen that the last score of the utilizing the ruler procedure at table C is 3, which is in this word shows that it should be decreased further later on, and changes might be needed to accomplish it. That's all from me. Thank you.
Now I'm going to talk about engineering drawing of our project, which is vehicle integrated parking system. First of all, we are adopting the final concept and interpret in the designing software. Number two, we translate the dimension and size onto engineering drawing format for the documentation. As you can see, there are two diagrams in the slide, which is the first diagram is our project diagram, and the second diagram is the part and the material we use in this project.
The material our group will use is TPU filament, which costs 19 cents per gram, and we will use about 500 gram. Secondly, we will use gear and rack, which costs 6 ringgit and 20 cents per set, and we use 2 sets. Next, we use 360-degree servo, which costs 6 ringgit per piece, and we will use about 5 pieces. Last but not least, we use 12-ply PVC board, which costs 10 ringgit per ply. We use SolidWorks software to design our project, and the tools we use is 3D printer for fabricating and designing our projects. Next, we use hot glue gun, which we use to assemble and combining each part. Secondly, we use sandpaper to smoothen or make rougher surface of a materials, and we also use hand saw to cutting, and last but not least, we use drilling machine. As the conclusion we can say is, nowadays, speed and easier process is the necessity in searching for parking space. This project extracts the consumer needs into developing a smart parking system that meet the market demand in a smarter way, while fulfilling the objective and scope during the meticulous process in designing the prototype. Our smart parking system will definitely benefit the user. Thank you.